Hello, everyone. Welcome to the Meritnation YouTube live session. Hello, Hitansh, Parth, Shreya, Aditi. How are you all? Hello, Kishore, Varsha. Yeah, Aditi, I know that. So, student, this is our first session of rotational motion. So, we'll start in a minute. Okay, let's start now. So you can see on your screen, student, question from JEE 2011. Okay, so you can see 4 solid spheres, each of diameter √35 centimeter and mass 0.5 kg are placed with their center at the corner of side 4 centimeter. Okay, and the moment of inertia of the system about the diagonal of the square is n into 10 raised to power minus 4 kg per meter kg meter square. Then we need to find out the value of n. Okay, before this, let me ask you a simple question here. Suppose this is the solid sphere. And you know very well moment of inertia of a solid sphere about its axis is what? 2 by 5 mr square. 2 by 5 mr square. Okay, so if I'll ask you, find out the moment of inertia of this solid sphere about this axis. So can you tell me the moment of inertia of this solid sphere about this second axis? And we know that moment of inertia of this solid sphere about this first axis is 2 by 5 mr square. Okay, so can you identify the theorem which we can use here to find out the moment of inertia of this solid sphere about the second axis? Is there anyone who can tell me the theorem? Okay, movie, you are saying 7 by 5 mr square. Good. Can you identify the theorem? Perpendicular axis theorem or parallel axis theorem? Which one? Yeah, exactly. Parallel axis theorem. Good. Okay, exactly. Good. Awesome. So student, first of all, let me give you idea about the moment of inertia. Okay. So, you know, suppose this is the axis, and suppose a particle is lying here at a distance r from this axis. Okay, and mass of this particle is suppose m. Okay, and it's a point mass. So moment of inertia of this particle about this given red color axis is what? I is equal to mr square. You know that. This is equal to I is equal to mr square. Okay. So, you know, similarly, we have already calculated moment of inertia of a solid sphere, hollow sphere, solid cylinder, hollow cylinder, ring. So let me show you first here. For solid sphere, moment of inertia is what? About its axis is 2 by 5 mr square. And what about the hollow sphere, student? Tell me the moment of inertia of a hollow sphere about its axis. Is there anyone who can tell me? Come on. So come on, students, tell me moment of inertia of a hollow sphere about its axis. Come on, you can tell me. Jaldi. Yeah, exactly, Hitans. Good, beta. Yeah, exactly. Hitans, Piyush, Varsha. Good, awesome, beta. Yeah, exactly. 2 by 3 mr square. Okay, good. And what about the solid cylinder? Solid cylinder, student. Solid cylinder. Hollow cylinder. Come on, tell me about its axis. Yeah, for Subhash, for solid cylinder mr square by 2, and for hollow cylinder mr square. Okay, and similarly, if you talk about the disk, ring, Okay, or we can say that triangular plate. So for disk, I is equal to mr square by 2, and for ring I is equal to mr square. And what about the triangular plate? Is there anyone who can tell me the moment of inertia of a triangular plate about its base? Is there anyone of you? Is there anyone who can tell me moment of inertia of a triangular plate about its base? I'm talking about the base, beta. Anyone of you? So see here, suppose a triangular plate. Don't know? Okay, just a second. And suppose this is the base of this triangular plate. No answer? Okay, don't worry. And see here, this is the base. And suppose this is the height of this triangular plate. So beta, moment of inertia about its base is I equal to mh square by 6. Okay, mh square by 6. Okay, and one of the important moment of inertia here is for cube. Is there anyone who can tell me moment of inertia of a cube about its axis? Let me show you the figure first. Here you can see the figure. This is the cube. Okay, cube of side A, suppose. Cube of side A. And suppose if we'll draw here front view of this this cube. So this is the front view, suppose. And I'm talking about moment of inertia of this cube about this axis. About this axis. Is there anyone who can tell me moment of inertia of this cube about this axis? This is the front view of this solid cube. Come on. It's a cube of side A. Okay, so someone is saying, is there anyone? Come on, Varsha. Okay, Varsha, you are saying ml square by 12. Okay. I'm talking about this cube of side A. Anyone of you? Most of the students are saying ml square by 12. Okay, Varsha, you are also saying ml square by 12? Beta, ma square by 6, no? Ma square by 6 is the moment of inertia of this cube about this axis, no? Ma square by 6. Okay, ma square by 6. Okay, so now we know that moment of inertia of solid cylinder, solid sphere, hollow sphere, disc, ring, triangular plate, and this cube as well. What about rod, beta? What about moment of inertia of a rod about its axis? Anyone of you? Come on. What about this rod about this axis? Tell me. Suppose mass of this rod is m and length is l. Yeah, exactly. Good. Absolutely correct. This one, for this one, I is equal to ml square by 12. Okay. Yeah. No, I'm talking about this axis which is passing through the center of mass of this rod. Okay. Later we'll talk about the end of the rod. Okay. So now move on to the next part, that is parallel axis theorem. So students, now let us discuss about, let me give you idea about parallel axis theorem so that we can discuss our question. Parallel axis theorem. So students, let us assume that this is a system. And suppose center of mass of the system is here. Okay, suppose this is lying at this P point. And this one is the axis which is passing through the center of mass of this system. and moment of inertia of this system about this axis is what? ICOM. Okay, so moment of inertia of this system about this pink color axis which is passing through the center of mass of the system is what? ICOM. Okay, and suppose we have one more axis, this one, this red color axis, which is parallel to given pink color axis. So beta, suppose this one is a second axis and this one is first axis. So second axis is parallel to given pink color axis, and suppose the perpendicular distance between them is what? Here we can say, suppose D. Okay, so D is the perpendicular distance between them. Okay, this is the D. So my dear student, we know that moment of inertia of this system about this pink color axis which is passing through the center of mass is ICOM, and we can use parallel axis theorem to find out the moment of inertia of this system about this red color axis, and that is equal to what? So moment of inertia about this axis is ICOM plus md square. What is m here? M is the mass of the system and d is the perpendicular distance between these two parallel axes. Okay, now we have idea about the parallel axis theorem. So now let us discuss one question here. So suppose a metallic ring, suppose this is the metallic ring, okay, and one cube is in contact with this metallic ring. Suppose this cube is in contact with this metallic ring. Suppose mass of this ring is m, okay, and radius is suppose r here. Suppose see, this one is suppose r. You can say that suppose this one is 2r. Okay, radius is r and this height is what? 2r. Basically it's a diameter. And what about this one? Suppose r. Okay, and here mass of each side of this metallic square is suppose, for this metallic square is suppose m. Mass of each side is m. So we have to find out the moment of inertia of this arrangement about this blue color axis. So I'm giving you 2 minutes. Please try this question. You can try. Come on. Find out the moment of inertia of this arrangement about this blue color axis. But you can see first one, you can see here, if we talk about this pink color, so it's basically a ring, metallic ring of radius r and mass m. Okay, and one more metallic square whose side is r in contact with this pink color ring, you can see. So basically we need to find out the moment of inertia of this arrangement about this blue color axis. Okay, and here mass of each side of this this square is what? M. So you can try. Come on. Come on, students, you can try. Okay, so Subhash, your answer is 3/2 ma square. Okay, fine. I'm talking about the whole arrangement. Yeah, I'm waiting. Yeah, I'm giving you 2 minutes. Okay, so your answer is 19/6 mr square. Okay, fine. Okay, so let's start now, students. So first of all, here you can see, let us discuss about this for, we can divide this arrangement in 5 parts. First one is for this metallic ring. Okay, second one, this side of the square. Third one, this is the fourth one, and this side is fifth one. Okay, and let us find out moment of inertia of this ring about this blue color axis. So suppose this was the ring, okay, and this is the axis, this one. You see, okay, and here you can see, you know very well, moment of inertia of ring about its diameter is what? About its diameter is mr square by 2. Okay, about this axis, moment of inertia of this ring, just a second. Okay, about this axis is mr square by 2. mr square by 2. Okay, and so, and the perpendicular distance between these two axes is what, beta? R na? Okay, perpendicular distance between them is r. Now we can use parallel axis theorem to find out the moment of inertia of this ring about this blue color axis na? So see here, I is equals to what? You know, I com plus md square. Okay, so here moment of inertia of this ring about its center of mass is mr square by 2. No? So this is mr square by 2. See, this one here you can see. mr square by 2 plus this one is m, and the perpendicular distance between them is r, so mr square. So this is equal to 3 by 2 mr square. Okay, so here I1 is equal to 3 by 2 mr square. It means moment of inertia of this metallic ring about this blue color axis is 3 by 2 mr square. Now move on to the second part, this one. This one, no? Okay, and we have to calculate moment of inertia of this rod about this blue color axis. So now we know very well, beta, if we have given a rod, okay, rod, and moment of inertia of a rod about its axis, about its center of mass is what? ml is square by 12. And about its one of the end is what? ml is square by 3. So similarly, length of this rod is what? R. Okay, length of this rod is r and mass is m. Then moment of inertia about this axis is what? Here I2 is equal to mr square by 3. Okay, this is the moment of inertia of this second part. Now move on to the third part. To see here, now this one, I'm talking about this one, this side. So this is the axis. Okay, and we have to calculate moment of inertia of this axis about this blue color axis. So my dear students, see here, the perpendicular distance between this blue color axis and this rod is what? That is to r. Here you can see r. Na? So we can divide this rod into number of particles. Suppose let us divide this rod into number of particles. See here, we have divided this into thousands of particles. And distance of each and every particle from this blue color axis is what? M. Okay, so each and every particle is at a same distance from the axis. So, and let us suppose that mass of first particle is m1, for second one m2, similarly for third one, fourth one m4, m5, m6, so on. So what will be the moment of inertia of this entire rod about this blue color axis? And that is equals to what? Here m1 r square plus m2 r square, so on. So we can take r square common. Then what we'll get here? m1 plus m2 plus m3, so on. It means m1 plus m2 plus m3, that so on, that will give you the mass of this entire rod. It means moment of inertia of this rod about this blue color axis is what? Simply mr square. And this is our third part, moment of inertia of this side. We can say that moment of inertia of this AB about this blue color axis is what? mr square. Now move on to the next part. Now similarly, we can calculate moment of inertia of this BC part, this section BC. Okay, and you know that will be equal to what? Here if we talk about the fourth part, here you can see, we'll talk about the fourth part. So here I4 is equal to mr square, mr square by 3, because this is the rod, okay, of length r, okay, and mass m, and this is the axis, no? Okay, and this axis is passing through the one of the end of the rod. So that will be equal to what? mr square by 3. This is I4. Now, last part beta. What about the fifth axis? What about fifth axis? Fifth one, this one. Fifth side. Let us suppose this one is CD. Okay, moment of inertia of this section CD. See here, this is the rod. This is the rod. Okay, and axis is also passing through the same rod. No? So now tell me the value of I5. Okay, good, great. So most of the students are saying 0. Absolutely correct, beta. Good. Why? Because beta, if we'll divide this rod into particles, suppose we have divided this rod into number of particles, and beta, each particle is lying on the rod, on the axis. No, each and every particle is lying on the axis of this on this blue color axis. Okay, so perpendicular distance of each and every particle is 0, and if perpendicular distance is 0, that's why moment of inertia of this section is 0, no? Okay, so now we have calculated I1, I2, I3, I4, and I5. And if we'll talk about the entire moment, if we'll talk about the moment of inertia of this entire arrangement, so what we can do here, simply I is equal to I1 plus I2 plus I3 plus I4 plus I5, and that will give you the moment of inertia of this entire arrangement. Okay, so I gave you the concept of parallel axis theorem here so that we can use this theorem in our first example. Okay, so finally we'll get here after adding I1 plus I2 plus I3 plus I4 plus I5, we'll get the final answer. That's it. Okay, so this will be our final answer. After adding, you'll get the answer. Rest of the part is calculation. Okay, and you can easily do the calculation. So now move on to the our first question. You can see here this one. 4 solid spheres, each of diameter root 5 centimeter. Okay, so here diameter is given root 5 centimeter. Okay, what will be the radius then? D by 2. Okay, it means root 5 by 2. But this one is in centimeter. So what we can do here, we can convert this centimeter into meter by simply multiplying 10 raised to power minus 2 meter. So this one is the radius of this solid sphere, and you can see mass of this solid sphere is given 0.5 kg. You can see, okay, and placed with their centers at the corner of side 4 centimeter. Okay, so see here, the side is given here 4 centimeter. Okay, so the value of A here is 4 centimeter, or we can say that 4 into 10 raised to power minus 2 meter. So now let me draw the diagram of this question. Okay, so see here, beta. So this one is the diameter, na? See, and first solid sphere is here. Second solid sphere. And this one is the third one, and the last one is, you can see here, fourth one. Okay, and beta, we have to find out the moment of inertia about this pink color axis. This one is passing through the diagonal of this square. So you have to find out the moment of inertia about this axis. Okay, so students, you know very well, here we have given solid sphere. Okay, solid sphere, na? Solid sphere, and you can see moment of inertia of a solid sphere about this axis is what? You know very well, that is equal to 2 by 5 mr square, na? 2 by 5 mr square. Okay, so suppose this one is our first solid sphere, second, third, and this one is suppose fourth. So now we know that moment of inertia of first solid sphere about this green color axis is what? About this green color axis is 2 by 5 mr square, but we have to calculate moment of inertia about this axis AB. Okay, so how can we find out the moment of inertia about this axis, about this pink color axis? By simply using parallel axis theorem, because here the perpendicular distance between first solid sphere and this pink color we can find out the perpendicular distance between them. How can we find out the perpendicular distance between them? You know that, simple mathematics. Suppose distance between them is d. Okay, so students, let me first find out the perpendicular distance between them. See, suppose this is the square, this side is, suppose this side is, this one is A and this one is A. Okay, and by simply applying Pythagoras, we'll get the length of this AB, na? Length of this AB, or we can also get this length here, this one. This one is length A, and this side is what? Root 2A. Okay, but we need half. Suppose this is the center and this is P, this is A. So here AO is what? AO is half of root 2A, na? It means A by root 2. So this is the perpendicular distance between the between these two axes. So here D is what? A by root 2. So later we'll use this point, this one, A root 2. Okay, so now what will be the moment of inertia of first sphere about this pink color axis beta? I1 is equal to 2 by 5 mr square plus m into d square. And here d is what? A by root 2 whole square. Okay, this is the moment of inertia of first sphere about this pink color axis. Okay, and what about this? What about the second sphere, student? Here, second sphere is this. Beta, for second sphere, this pink color axis is passing through the second sphere. Na? Okay, so simply we can say that moment of inertia for second sphere about this pink color axis is what? 2 by 5 mr square. Simple. Okay, now what about the third sphere? For third sphere, see here, this is the axis. Na? About, we know that moment of inertia about this axis of solid sphere is what? 2 by 5 mr square, and the perpendicular distance between them is d. So simply use here 2 by 5 mr square plus m, and d is what? A by root 2 whole square. This is the moment of inertia. Exactly, movie maker. So moment of inertia of third sphere about this pink color axis is what? 2 by 5 mr square plus m into a by root 2 whole square. Okay, just a second, Hitansh beta, just a second, give me a minute. Okay, and what about the fourth sphere? Yeah, you can see, if we talk about this pink color axis, that AB axis is passing through the fourth sphere. Na? Okay, so we can directly write here, na, I4 is equal to 2 by 5 mr square. Moment of inertia of this fourth sphere about this pink color axis is what? About this axis, 2 by 5 mr square. Okay, so now we have calculated here moment of inertia due to first, second, third, and fourth sphere about this pink color axis. So for moment of inertia for entire arrangement, what we can do here? I is equal to I1 plus I2 plus I3 plus I4. Okay, so you can add them. Okay, you can put the value of r. You know, radius is what? Root 5 by 2 here. Root 5 by 2, or we can say that root 5 by 2 into 10 raised to power minus 2 meter. And what about this? What about the value of a? A is already given. Na? Here side a is a side, na? That is equals to 4 centimeter, or we can say that 4 into 10 raised to power minus 2 meter. Okay, after putting the value of r, a, and mass, that is equals to 0.5, you'll get the final answer. And with the final answer is 9 into 10 raised to power minus 4. Okay, this is the final answer. Okay, so in this question, we have to calculate here the value of n. Okay, and the final answer is what? 9 into 10 raised to power minus 4. So here n is equal to 9. That is the final answer. Okay, so that is the final answer. So I gave you the idea about this question. We have discussed about the parallel axis theorem. So any issue, any one of you in this question? I hope you understood. Clear, beta? Okay, so now we can end this session. So students, to know how Meritnation can boost your preparation for JEE 2019 with power-packed premium courses, go to this URL beta, URL. Okay, and so student, we'll meet on upcoming session for this rotational motion. Okay, we'll be having 2 more sessions for this chapter. Okay, so we'll meet on Wednesday. So thank you so much, everyone. Take care. Bye bye. Thank you so much, everyone. Thank you.